All right, today we're going to go over a double pulley system. Okay, we're going to do a single fixed, single movable with the effort going up, and a single fixed, single movable with the effort going down. So the big distinction between the two pulley systems is the direction the effort goes. Okay, so just like before with a single fixed pulley or a single movable pulley, make sure that you take your rope, go through the metal bar. Okay, then the trick is it's actually got two pulleys, so you need two pulleys, right? A single fixed and a single movable. So once the rope's hanging through the first one, you're going to take one of the ends, it doesn't matter which end, and you're going to go through the bottom silver part on the other pulley system. Okay? What that does, take your single fixed one, attach it to the binder clip, it's still a single fixed. Then if you take the rope that you fed through the bottom of the pulley wheel, pull that on up and let it hook onto the hook of the fixed pulley, then you end up with a single fixed and a single movable pulley system. Okay? This happens to be the single fixed, single movable with the effort going down. You can see that because I'm going to pull down on it. Okay? Make sure that that rope stays in the pulley wheel. Okay, it has to be in there. So then what you'll do is you'll take your load. Okay? Load gets attached to the movable pulley. The pulley that moves, right? The single fixed pulley stays there, okay? And then your effort attaches onto the loose end of the string, and that's where you'll apply that force. So use that paper clip to attach it on, like you always have. And then you can lift the load and measure how many newtons of effort it takes to lift the load. All right, so this is a single fixed, single movable going down, okay? Because this pulley wheel moves and this one's fixed. Single fixed, single movable, effort going down, okay? The easiest way to get from a single fixed, single movable with the effort going down to a single fixed, single movable with the effort going up is to take your load and spring scale off. Notice how I'm holding on to the bottom pulley wheel. You guys see how I'm holding on to the bottom pulley wheel? And you're gonna flip it. Okay, you literally take the pulley system, make sure you're holding on to both pulley wheels. You don't have to take the rope off. And you flip it. As soon as you flip it, you've all of a sudden got a single fixed, single movable with the effort going up. When you attach the effort on this one, you use the hook at the bottom of the spring scale, attach the rope onto that hook, and your load still attaches onto the movable pulley. Okay, so the big difference is the direction of force, the direction you apply the force. Okay, so single fixed, single movable, with the effort going up, and then that'll allow you to measure how much effort it takes on each of those pulley systems. Okay, let me show that to you one more time. This is a single fixed, single movable, effort going up because I'm pulling the effort in an upward direction. If I take all the items off, spring scale and load, and I hang on to both pulley wheels and I flip it, I get a single fixed, single movable with the effort going down. Load always goes on the movable pulley. Effort goes on the other end of the rope. Okay. This one's a little bit trickier in making sure that your rope stays in those pulley wheels. So if it happens to fall out or slide out, make sure you guys get that put back on. Okay. Single fixed, single movable, effort going down. Flipped change. Okay. And then I'm going to show you guys really quickly how to diagram and run through just a couple of the errors that you guys tend to make when diagramming this particular pulley system. Okay. Like always, I will give you guys stickers for the pulley wheels. So I'll give you two circular stickers for the pulley wheels. Think about what the pulley system looked like in order to figure out how you're going to diagram it. Okay. So when you guys get your stickers, and you just kind of have to experiment with it. You'll stick a sticker on. I like to offset them just a little bit. Not a lot, you don't want it way over here, but offset them a little bit and leave enough room. Okay, so you'll get your pulley stickers. You'll put them on your page, and then you'll need to label the fixed point, right, which is always going to be off of that first pulley, that top pulley, because it's the fixed pulley. Okay. And then you're going to attach your rope. Now, one of the easier way to think about attaching your rope is to think about that the rope connects from one pulley wheel on the hook down to the other, and then comes around the pulley, back up to the other, and then loops down. Okay? My load goes down at the bottom, L for load, attach on, circle representing the effort, right? And then I draw the direction of the force that's applied. So this particular pulley system is a single fixed, single movable, going down, okay? So you identify it by the direction that you pull. So think about the direction you pull. So then when you're going to do the other one, right, you want to think about the fact that, well, if I went this way first and I ended up, when I drew the line, I came down and I went towards the right as I drew the line to get my single fixed, single movable going down. If I go towards the left, I'm going to end up with a single fixed, single movable going down just on the other side. So really think about the direction that you need your force to go as you diagram. Remember, when you guys diagram, don't go across the pulley wheel. You guys have a tendency to want to leave floating ropes, floating pulley systems, or cross the pulley wheel, and none of those things happen on the pulleys that you build. So as you guys diagram, when you make those pulley wheels, make sure that you always label your fixed point, whatever it is, and that the rope is attached to the pulley wheel. Okay, it's right next to it without those gaps, but it doesn't cross over it, right? Nor is it floating away from it. It has to be right on the pulley wheel. So the correct one goes correctly on the pulley wheel, okay? Make sure that that happens. Label fixed points. Yes, you have to write it out. It's not very long, fixed point, right? Okay. And then you can finish diagramming out any double pulley systems, okay? If I want my effort going up, you can see that this one needs to come over, attach to the pulley wheel, which will allow this rope to come around, and my effort's going up. So now I have a single fixed, single movable with the effort going up. And this is how you would abbreviate for those. Much easier than having to write out every time single fixed, single movable. So you guys are going to be diagramming these, okay? Don't forget all the little details. Add your load, direction that it's going to go. And then after you guys have built them and diagrammed them, in the next lab you'll get to actually experiment with them and see how the amount of force needed to lift the load changes with each of these pulley systems. Okay?